Hi there, I'm Shahrad Shaukat, and this will be a two-part video series in which I will be covering bezier curve drawing algorithm. And the first part of this series will be building an application in Java, rather an interactive bezier curve drawing application, followed by building a same application in Opengl in C. I take into account that you all aware of bezier curve drawing algorithm. If not, let me give you a short description about it. So bezier curve precisely have n control point where n plus 1 is the degree of the Bezier polynomial. To create a large curve, it is necessary to connect multiple Bezier curve. Note that Bezier curve pass through the first and the last control point, and the Bezier curve always lie within the convex hull of the control point. And one more important thing, and they have always sum of the basis function at 1. So as you can see from here, there are four control points: B0, B1, B2 and B3, and the curve passes from B0 and B3, none other than that. The rest control point, the curve doesn't pass from it. So this function gives a point on a curve where this t can be any value between 0 and 1, and n is the number of point minus 1, where b is a point, bth control point, and j is a blending function. To calculate the blending function, you can use this formula, and this is the final final formula for calculating the point on a curve. This formula is for 4 control point. Similarly, you can calculate for 5 or 6 control points. So I hope you are now good enough to proceed forward. Now before going to the source code, let's check the final application in Java and Opengl. So this is the final application, bezier curve application. So we can draw a curve, select do a point. The first point is 90, and here is the coordinate of the first point. Second point, coordinate second point, and draw the curve. So this is our curve. New. Draw some more curve. This is the curve. Draw the curve. 2 point. More points. More point. Let's draw the curve. So it works for n number of points. Some more points. So this is a bezier curve application in Java. Now let's check in Opengl. So this is a bezier curve application in Opengl. We can use our mouse to draw points. My first point. We even can clear it. Caps lock clear. So we can draw the points. Therefore, they are the 4 points. Draw a polynomial and draw the curve. Clear it. Even if I want to try this. Oh, what the? Something gone wrong. Compile it once again. So we were here. Draw this point. but something went wrong during that point. So it's all about how much step you take to draw this curve. More number of step, then final will be the curve. Actually, you have to vary that variable, the t variable that I mentioned earlier, that it will vary from 0 to 1. If there will be a more number of step, lesser the incremental t value will be smaller, and the smooth, you will get a smooth curve, but it will take, definitely it will take some more time to compute the curve. So let's say now, let's say you have seen the final application. Now let's check the source code. Definitely I will add some more functionality to this application, some buttons here to draw, clear, exit, as there was in my Java application. So let's check the Java application first, then I will be covering this application in Opengl. There are 4 classes in my application: algorithm class, display class for displaying, and data class. Data are shared between among the different classes, and main class, application class. So first we will look the data class. These are the data that are being shared among the different classes. There are a set of control points, points that lie on the curve. After calculation we get this. So these are the functions and data in the data class. This is our app class. There is one we have created object. This is the panel that you see here. The panel that you see here. This is actually a display class, object of the display class. We extend jpanel. So to get the point on the panel, to get the point, to get these point on the panel, I have used add mouse listener, and I use a public void mouse click. Whenever we click click on that panel, a mouse click on that panel, we get the x and y, relative x, y and y coordinate, and then I insert these x, y coordinate in data, that control point, it get inserted, and we increment the number of control points. So by this we get the number of control point. After that control point is we get the control point, then we process these control point in our algorithm class. So this is our algorithm class. So it is a u variable that I discussed, that I mentioned, that t, that it varies from 0 to 1. Here the incremental value is 0.02. You can take any value. The lesser the value, more will be the number of steps, and the finer will be a curve, smoother will be a curve. So we have to get the blending function and the value. So compute blending function for kth variable ku, where k vary from, here's a loop, k vary from 0 till n, not actually n is here number of point minus 1. If you let me remind this, so we were calculating this, and we will part this value for calculating this. This is a point, we will get it from the control point, and to calculate this 30, we are creating a function, blending function. This compute blending function, we are passing the subscript, as you can see from a ku and value. This is a value and it's a kth subscript. So here no, actually do you want to find this? In order to find this, we are passing the value also and the subscript, which subscript we want. This, either want this one, or this one. So we are passing to the blending function to get the blending function, and this is our blending function, compute blending function. So it returns a double value. uh, as you know, the formula for the blending function was this one. This was the formula. We have to calculate the factorial n factorial I factorial minus 1. For that, I made a factorial function. So in this order, we get the blending function at particular value of u, where u varies from 0 to 1. And finally, after this loop, after completing this loop, we get a value, x and y value, for particular value of u. So when we pass this value into curve point, actual curve point here, actual curve point, this set of points, and when this algorithm finishes, let's say the draw curve is get one, and the display class display it. So it was a very simple application to develop bezier curve drawing application. So I hope you like it and you enjoy uh, it. So thank you for watching my video, and hopefully next time I will be describing what I have done in Opengl. So goodbye.